Today we'll finish up lesson B. We did most of the formulas yesterday for planar figures, things that are 2D. Today we're looking at volume and surface area. So those are our three-dimensional figures or our solid shapes. So starting off, if I have a shape like this, it is a prism. A shape like this is a cylinder. We are talking about things that have two bases that are identical and match up, and the sides go straight up. If it is turned so that the matching sides are like the floor and the ceiling of the figure. So here I have a prism. The top's a pentagon, the bottom's a pentagon, and the sides go straight from the top to the bottom. However, remember, I could turn it on its side. So watching some pictures, maybe it's still a prism, but it's just sitting on its side. The matching ends are the left and the right instead of the top and the bottom, and the sides go straight from one of those to the other. So this, let's see, where's another one? This one is another prism, much like the picture up there. The top and the bottom are triangles, and the sides go straight up and down. The cylinder would be the same idea. The top and bottom are just circles, and the sides go straight from the bottom circle up to the top circle. Does anybody remember the formula for a volume of these in general? So one formula that works, whether it's got a circle or a triangle or a pentagon on the top and the bottom of that. Riley? Excellent. Area of the base times the height. That's the one you want to remember. We're going to write down the next one, but you don't need to remember it separately, because what you're going to do is you're going to look at your shape. If it was the triangular prism, the base is what shape? The base is a triangle, and the formula for the area, this would mean area of a triangle. So you'd put in 1/2 little b little h, meaning how long is one side, and then how far straight to the other vertex of that triangle, times the height of the whole thing. If it happens to be a cylinder, what shape is the base? Not the formula. What shape is the base? And what's the formula for the area of a circle? So we would just change the area of the base then to a pi r squared times the h. So we've memorized the formula for the area of the base. We memorized the formula for prism or cylinder volume. And then we just put one formula inside of the other when we need it. Now let's suppose that I have a cone or a pyramid instead of a prism. So that means I have shapes like you see in these pictures, where I have just one base and the sides slant up to a point. Now, I'm wondering how the volumes are related for a cone or pyramid compared to the area of the base times the height one that we just talked about. So here I have a cylinder, here I have a cone, both have circles for bases, and those circles are the same size circle. Does the cylinder or the cone have a bigger volume? The cylinder. Anybody remember the fraction that we need in there? What's it going to be? 1/3. And let me also show you on this one. Here I have, they both have a hexagon for the base. And this pyramid also, it takes up less volume than the cylinder. So we want to memorize this formula. that if the sides slant to a point, the volume is 1/3 area of the base times the height. We're going to do the same thing that we did before. We're going to say, oh, what shape is the base? What does that AB need to be in this formula? If it is a triangular pyramid, my base is a triangle, so I need a 1/2 little b little h. If it is my hexagonal cone, I need the area of the hexagon times the height times 1/3. I don't have a formula yet for area of a hexagon. You'll learn how to calculate these areas next year. But if they gave me a number, if they said this base was 65 square units for its area, I could put the 65 in here times 1/3 times the height, and the height goes from the point to the middle of the base. However, if it is a circle and the base is a circle, what's my area of a circle again, everybody? I just changed this AB to a pi r squared, so I have 1/3 pi r squared h. I don't memorize the circle ones separately. Okay, this one may be a little bit harder to remember, but I am curious, does anybody happen to remember your formula for the volume of a sphere? And Alex? Excellent. After we have both volume and surface area formulas up here for a sphere, I'll kind of talk about what helps me keep them straight. For right now, I'll just let you make sure you copy that down accurately. And then I'll move on to my next slide and we'll talk about surface areas of things. Pretty much got that one down. Does anybody need me to wait before I go to the surface area formulas? When we talk about surface areas, we talk about lateral surface area and we talk about total surface area. And if it just says surface area, that means the same as total surface area. Can anybody tell me in general, what are we talking about when we talk about either surface area or lateral surface area? And I don't want you to let Alex do all the work for the class. Just the idea. I'm not asking for any formulas yet. What's the idea? What am I talking about when I talk about surface area of some shape? And Ellie, say that a little bit louder. Okay, and sometimes we do talk about the nets, and I'll show you those here in a minute. Anybody have a different way of describing what we're talking about when we talk about surface area? Because if we took one of these and we then unfolded it so that I had a net of all of the sides on here, then what would I do with these different, in this case, rectangles and pentagons that I'm holding here? What would I do to get surface area? What would I need to do on that one? I need to figure out the areas of each of them and add them all together. So total surface area is the area of all of the surfaces totaled up and added up. What's the difference when we say lateral surface area? Does anybody remember how that is different from total surface area of what we have going on with that, Jace? So the lateral does not include the bases. So if it's a cylinder or a prism, there are two bases we aren't including, the top and the bottom. That comes into play, especially when you're painting a house or a room and you're trying, well, do I need one can of paint? Do I need one big one and one little one? Or do I need 5 cans of paint? How much and how many coats am I going to do? Well, I'm not going to paint the ceiling and I'm not going to paint the floor, but I'd figure out for the walls. And then, yeah, I could subtract the parts I'm not going to paint, like the cabinets and the windows and the doors and things. But that's the big time when we do just lateral surface area. So if I am doing total surface area, I have two bases. The one I'm holding would be two pentagons, and then plus this part that unfolds kind of like a label that could wrap around those sides. And notice if it's a cylinder or a prism, I get one big rectangle if I put all of those sides together. So everybody see that much? And the area of a rectangle, I need to know how tall it is and how long it is going across. Well, how tall it is the same as the height of the whole prism or cylinder to begin with. So that's where the H comes from. And you can see on this net that I'm holding, if I wrap that long rectangle around, it just touches all of the edges of the pentagon. It matches up with the perimeter of that pentagon. So that's why I have the perimeter of the base in here. Does the second formula make sense? And then the first one just not include the bases. So these were the two bases. So if I don't include that, I still have the PB times H. Yes, Alex. I usually write SA. I'm not sure what. Oh, yeah, you don't have to have the TSA on there. That was just for emphasis on this one. I usually do write SA equals. And sometimes I need to do a subscript SAC equals and SAP equals if for some reason I have a cone and a pyramid in the same problem, just so I can tell which one's which. But if I only have one, I just do SA. Okay, if it happens to be a cylinder, like we saw before, the two bases are circles. What's the area of a circle? So I'm going to put a pi r squared in there. And perimeter of a circle is 2 pi r. It's the circumference. So I just change the area of the base and the perimeter of the base to the circle formulas. But I don't memorize that formula number 20 separately. I use number 19 and substitute into it. Now, if we start talking about pyramids and cones, it becomes a little bit different in there. First off, we have only one base when we are talking about a pyramid or a cone. And let me get hold of a couple of them here. So this one is a square pyramid, so it has one base. So I would need to get the area of one square. And now my lateral surface area is what kind of shapes put together? Triangles. So I've got 4 triangles, and any one triangle has an area. What's triangle formula again, everybody? So area of the base, so how long this edge is, that was one side of the square, times the height, which goes from the middle of the bottom of that triangle, so the middle of one side of the squares, and it slants. The height of this triangle goes up to the point of the triangle, so it slants. Now the height of the whole pyramid went from the top to the middle of the square. The height of one triangle, the little h, goes from the top to the middle of the bottom side of one of those triangles. So I think about the whole pyramid. The way I'm holding my hand right now, this is the height of the whole pyramid, but the height of a triangle slants and is longer. And we call that the slant height. So if I took this triangle, 1/2 this BH over to, or 1/2 this BH, 1/2 this BH, 1/2 this BH, and added them up, I would have gone all the way around that square, giving me the whole perimeter in there. So I have one base plus the perimeter when I put all of the triangles together, L for the slant height of the whole pyramid, because that's the height of one triangle, divided by 2. Now, if we have a cone, this one still kind of looks like a whole bunch of little tiny triangles just in this particular model, the way they had to build it. In calculus, you'll actually derive that this still holds true for a circle. It's called taking the limit as these triangles get tinier and tinier and tinier bases so that they're no longer having any real length. They're just a point. But the formula is still the same. The circle has an area of pi r squared. The circle has a perimeter or a circumference of 2 pi r. So if I take the 2 pi r times L over 2, my 2's are going to cancel, and I just have the pi times r times that slant height. And the last formula for this lesson, surface area of a sphere. Does anyone remember that one? Alicia. Excellent. It is exactly 4 pi r squared. And don't recopy this one because you've already got it in there. I just want to write them where we can see them both at the same time, because I told you I would talk about what helps me remember them. We already wrote down that the volume is 4/3 pi r cubed. So surface area is in what kind of units? Square, so it's the one that has the square in it. Volume is in what kind of unit? So it's the one that has both of the 3's in it. They both have a 4 and a pi and an r, but the surface area is the squares, so it has the square. The volume is the cube, so it gets both of the 3's. If something else works better for you, use that, but that helps me keep them straight. Any questions on the formulas? All right, please open up your books to set B. Get out your homework papers. And let me know which ones you would like for us to do. Maybe you've already tried these, maybe you haven't yet. I would like for us to start maybe with something out of 6, 7, and 8. Because those are the ones that where I see volume or surface area in there. Anybody have a request out of those 3 first? 7? Okay, so 7 actually has 2 parts there. Number 7 wants us to get the area of the shape on the left and the volume for the picture on the right. And they tell us the picture on the right is a cylinder, and sometimes the book will use cylinder and sometimes prism for a shape like that. Some books only use cylinder if the base is actually a circle. But either word for our purposes means the sides go straight up, 2 bases with matching, that 2 bases that match, and then the sides go straight between them. So you can kind of see that in the picture. So if it is a cylinder or a prism, what is the general formula for its volume? And keep your formula pages out, because I'm going to ask you to tell me the formulas instead of me just saying, write this one down. I want you to try to practice remembering them or looking them up as needed there. Caden, would you tell me off of yours just the general formula that works for any cylinder or prism? Caden, look at your formula paper. We just wrote it down. Volume of a cylinder or a prism. That's if the bottom happens to be a circle. Look at the one up before that. Area of the base times the height. And the pi r squared one is not going to work because the base looks like that and it's not a circle. That's why we want to be sure we start with the general area of the base times the height. Everybody comfortable with that? So you see why they are asking us first to get the area of the base for this thing. So as you look at that shape, don't give me any formulas yet, but describe that shape. Looks kind of to me like what you see underneath a basketball goal, that key. But can anybody describe it as a couple of shapes put together or anything? Anybody who hasn't answered something yet? Harper, what shapes do you see in that shape I drew? Everybody good with half a circle and a rectangle? So our area of the base needs to be half a circle and a rectangle. So half, what's the area of the whole circle? And a rectangle is going to be base times height. So let's see, they gave us some numbers on that stuff. They said this was 3, this was 3, and they didn't tell me how long across the top there, but they told me this was a 2. So that means my radius is a 2, so I can say 1/2 pi times 2 squared. And so for my rectangle, one side's 3, what's the other side? What am I going to get for my other side, Allison? Everybody good with if that radius is a 2, that's a 2, that's a 2, so this has to be a 4. So we have 3 times 4. So it looks to me like we are getting, let's see, 2 times 2 is 4, divided by 2 is just 2. So 2 pi plus 12. And punch that in on your calculators for me and let me know what you are coming up with there. Maddie, what do you have? Oh, I'm sorry. I meant to call on Marlo. You just got a calculator. Marlo. 18.283. Anybody else get that? And what are my units again on this? Meters for this one? So that is my area that they asked me to find. Now for the volume, I need to take that area of the base times the height. And what's the height? 8. And am I just going to multiply 8 times 18.283? Or a better question, why is it a mistake to take 18.283 times 8? What is wrong with doing that? We don't allow that, and tell me the reason why we don't. Henry? Once you round, you can't use that rounded number any farther along in the problem. Because it's no longer accurate. It's no longer an exact answer. It's rounded. And when you then multiply that little round off error by 8, you get an error that's 8 times as big as the one you started with. And we only want an error that's maybe 1,000th of a unit, and that could get too big. So instead, we're going to take the exact one, the 2 pi plus 12, and multiply that by the 8. So we have 16 pi plus 96. And this time we'll have cubic units. And now we're going to put that in our calculators. And I want you to let me know once you punch that in what you get there. Bless you. Still see several people punching the numbers in on calculators. I'm just kind of waiting for everybody to get caught up here. All right, Maddie. That's what you said. Others, thumbs up or thumbs down? Is this what you also got? Since I see mostly thumbs up, that must be correct. And so there are 2 forms for our volume answer. Everybody comfortable with that? And let's see. Why don't we do number 6 next, just because it has a pyramid. thrown in there. So number 6 says the bottom is that scaling triangle, and then there are sides that slant up to all meet at a point. And so we need to find the volume of a pyramid. So what is the formula that you wrote down for volume of a pyramid? Ayla? So we need 1/3 area of the base times the height. So we need to figure out that base and then the height on it. What shape is the base? Triangle. So what's my triangle area formula? Everybody. So base times height divided by 2, or 1/2 little b little h. And then what's my big H for the height of the whole pyramid all the way up to that point? Ainsley? 10? Does that look right to everybody? So then we need to look at our triangle, and what should we use for the base and the height? I don't see a line going through the middle of the triangle somewhere like they usually draw the base. So help me understand what in the world is going on there. Clay? Use the 4 and what on the picture tells you yes, those two will work? Okay, base and height have to always make a 90-degree angle. And they tell us those do make a 90-degree angle, so Clay's exactly right. We can use the 4 and the 6. So I have 1/3 times 1/2 times 4 times 6 times 10. Hey, that's going to be pretty easy to clean up a little bit. What's 3 times 2? So I'm just going to cancel that 6, and 4 times 10 is, so it looks like 40 ought to be my answer. Does that look right to you guys too? And units? That makes sense? All right. The rest of our time is for you to get some work done. Is there anything else that you've looked at and were really confused about last night and want me to go ahead and talk about with the whole class? Or you just want time to work on getting it done at your own pace? I don't see any hands up. So if you do come across some questions, come up and ask me. But let's get as much done as we can. Has everybody signed up in Yasha to go to your 3rd period? And if you see any mistakes in 4, 5, or 6, let one of your teachers know so we can give you the link for that form. And we'll see if you got yours straightened out for today or not. I don't know what that was about. If it's the same error, we won't send it to him again. We'll figure he just didn't have time to do anything yet. And sophomores, raise your hands. Today you have your class meeting, but you go to 3rd period and wait for the announcement.